Hi, today we are going to look at the many-to-many relationships and why it is not allowed in relational database. A many-to-many relationship happens when both entities can relate to many instances of each other. This means one record in entity A can connect to many records in entity B, and at the same time, one record in entity B can also connect to many records in entity A. For example, a student can take many classes, and a class can have many students. So, the relationship between student and class is many-to-many. Now, the problem is that relational databases do not support many-to-many relationships directly. We cannot just add a foreign key on one side, because each record would need to store multiple values, which is not allowed in a relational table. If we try to force it, it will lead to problems such as data redundancy, where the same data is repeated, data duplication, and update anomalies, where changes become inconsistent or difficult to manage. This slide shows an example of the wrong way to implement a many-to-many relationship between student and class. In the student table, the class code is repeated multiple times for the same student. This creates redundancy, where the same student information appears again and again. In the class table, we also see duplication. Every time a student takes a class, a new class record is created, even though the class itself is the same. So, this design causes unnecessary repetition of data, making the database inefficient and harder to maintain. This slide explains why a many-to-many relationship fails when implemented directly. First, redundancy occurs because the same student data is repeated multiple times. Second, we have update anomalies. If we need to change one piece of information, we must update it in many rows, which increases the risk of inconsistency. Third, there are insert and delete problems. For example, we cannot add a student unless they are already linked to a class. Finally, queries become more complex because the data is not properly structured, making it harder to retrieve accurate information. To solve the many-to-many relationship problem, we introduce a new entity. This entity is also known as a bridge entity, associative entity, or linking table. In this example, it's called enroll, and its purpose is to break the many-to-many relationship into a more manageable structure by connecting student and class properly. With this approach, we can avoid redundancy and organize the data more efficiently. Now, we convert the many-to-many relationship into two one-to-many relationships using a new table called enroll. The enroll table acts as a link between student and class. Each student can have many enroll records, and each class can also have many enroll records. In this design, the enroll table contains foreign keys from both student and class. These two keys can also be combined to form a composite primary key. Also note that the student and class tables now contain only one row per entity. This approach removes redundancy and allows the database to manage the relationship in a structured and efficient way. So this is how we change a many-to-many relationship into two one-to-many relationships. Originally, student and class are directly connected as many-to-many. After introducing the enroll entity, the relationship is split into two parts. First, one student can register many enroll records. Second, one class can also appear in many enroll records. So now, instead of a direct connection, student and class are linked through enroll, making the relationship easier to manage and suitable for a relational database. Remember, we always read the relationship from the one side to the many side. The enroll table contains multiple occurrences of the foreign key values, but those controlled redundancies are incapable of producing anomalies as long as referential integrity is enforced. Referential integrity ensures that all foreign key values must match existing records in their related tables. This means we cannot insert a value that does not already exist in the parent table. For example, the STU num must exist in the student table, and the class code must exist in the class table. If the value does not exist, the database will reject the operation to maintain data consistency. To summarize, many-to-many relationships cannot be implemented directly in a relational database. Instead, we convert them into two one-to-many relationships by introducing a composite or bridge entity. This approach helps reduce data redundancy, improves data integrity, and makes queries simpler and more efficient.